When it comes to AI, the most important thing that you need to take into consideration is the way that the learning happens, the way that the models are being trained. So there are two types of learning when it comes to artificial intelligence. One is supervised learning and the other one is unsupervised learning. Supervised learning is basically training the algorithm with data that are labeled. Unsupervised learning means training the algorithm with the complementary, with data that are not labeled. What does it mean, labeled or not labeled? I don't know if you remember the times where you were learning in school and they would give you like a little learning card and tell you, oh, this is a car, this is number 3, this is dog, this is an apple. Well, something very similar. Basically, that is a type of labeled data. That is a type of supervised learning. In other cases, there are other things that no one tells you about in life and you end up figuring out on your own, like dynamics of work environments. You either learn on your own with unsupervised learning or you read a book about them and understand what each thing means. That is supervised learning. If we looked at real life examples with supervised and unsupervised learning, the moment that models are beginning to be trained with data, you didn't have labels for everything in the internet. For example, in the case of large language models, the way that they learn was from text from books, text from the internet, text from images on the internet, the alt text that those images contain, like a schema of the data, like different things. But there was other thing that couldn't be understood and more related to human language, like perceiving irony, perceiving sarcasm. And this was basically initially a situation with unlabeled data. Then the moment that, there was feature extraction type of word or determination of specific words are related to specific behaviors, then you were able to create your own labeling. But some things started as unsupervised learning and then developed into supervised learning over time. When it comes to supervised learning, like it didn't learn, like you wouldn't teach a computer, oh, this is a dog, this is a machine, this is a chihuahua, this is a whatever. No, it would show you this is a dog, this is not a dog. This was the labeling that was happening. This would allow a model to have a little bit more performance. They would do the same with every single other image available of not a dog, maybe a cat, or maybe a giraffe, something else, or maybe a leopard. And at some point there were like different recognitions of what these images corresponded to. And eventually this turned into more complex problems, like distinguishing whether this picture is of a dog or a muffin, things like that, or distinguishing whether this is a leopard or it's just some women wearing a leopard coat. To us it's common sense, right? But there is specific features, there's specific things, there's specific pixels that need to be there in order for it to be a human being or an animal. And same thing happens with the learning. And another case of supervised and unsupervised learning, I don't know if you know, like the face recognition that you use for your phone, basically that is a combination of supervised and unsupervised learning. On the one hand, there was an unsupervised learning, I think it was probably CNN. You have the problem of determining what are the most important features of a face, so basically determining the biometric features of a face. And then on the other hand, you have the problem of determining whether this is you or not. And in the case of determining the most important features of the face, it's basically out of a lot of pictures of someone, of different faces, determining where are the points with most information about a specific human being. What are the elements that make this face recognizable? Where are the patterns? When you're gonna use your phone for authentication, you're not gonna say, oh, I'm Karen, identify me. You're just gonna use your face and it should work. You're maybe not gonna use face recognition with your dog. Actually, this is an interesting case. Have you ever tried face recognition with your dog? Is it trained for that? Now I'm actually curious. Anyway, when it comes to determining whether this is you or not, like with the first video or the first image that you're actually taking of yourself, it finds those most important features of your face and then determines whether it's you or not. It's a 1 or a 0. And that is another example of supervised learning. So I think authentication, like phone authentication, is a pretty good example that combines both types of learnings. There are other cases, like very valid examples of unsupervised learning. For example, if you were to analyze the footage of an airport, like to determine whether some passenger is having like weird activity, how do you determine who has an activity that is irregular? You find patterns, and you don't need to tell it this is a traveler that goes to whatever. You don't need to do all of that. You can just dump all of the data and basically allow the algorithm to find patterns. You're gonna use something a little bit more sophisticated than a regular machine learning model. You're gonna going to use something like a neural network. The idea is that you actually allow the algorithm to determine the patterns. Humans, we are not as sophisticated to make those decisions because we mix emotions a lot. When it's determining any kind of decisions, we are not as logical as we should be for everything. For labeled data, they're simpler to understand data. Like, for example, how do you determine the price of a new property? The square footage for the specific area is at this price, then there's these things, but it's very difficult to take so many factors and making it objective. There's additional factors that customers take into consideration whenever they're determining an additional value to a property, like closeness to schools or a crime rate in that particular area, or other things that they might not tell you about but determines the value that a property might have in their eyes. If you were to determine the price, you can take the features of the house, like square footage, energy efficiency, the amount of rooms it has, whether it has wooden floors or not, whether it has a central heating system, whether it counts with sources of renewable energy of some sort, whether there is an automatic door, whether there's a security system in place, many different things. And all these things can determine the price. And this is basically just one example of labeled data. You have prices from the past that were determined from all these features, and with that, you're able to make a prediction of the price that a new property should have based on those features. It's basically a continuous value prediction. Continuous value is basically a number. But there are many other problems that AI can solve. For example, this case that I told you about with the real estate property price. This is a case of regression. A regression is basically going to predict a value based on different features, based on the features that you are providing within the training data. This real estate price prediction or a time series, time series is a different case. Anyway, so like this real estate problem, this is a regression type of problem. There's other problems that can be solved with AI. These are classifications, like for example, the sentiment. This is such a classic, but sentiment analysis, like when someone writes something, is this good or is this bad? This was having training data of tweets and trying to analyze the sentiment, or you interpreting from your own perspective, like, okay, based on human language, these words are associated with a positive type of message. There's also a mix of positive and negative, right? What can determine, like, is this a quantity of whether there's more positive words and negative that determines whether a tweet is positive or negative, whether it's neutral? This is a type classification. Classification happens with predefined categories. Categories can be about for something as simple as something is positive, negative, something is a 1 and a 0. Another type of problem, clustering. This is classic in unsupervised learning, right? We mentioned it before with understanding the most important components, or if you were seeing the footage of an airport, like determining which passengers are behaving similarly and how would you cluster them. A model is not telling you what these customers are doing. Well, that's another level of a model. An unsupervised learning type of activity will tell you which groups of passengers are behaving similarly. Then you will determine what this behavior means. You will apply the label. But initially, the model will not know what this specific group means. It will just notice that there are similarities in the way that they behave, in the frequency that they move, in the amount of pixels that they move per second, whatever you can think of. Then there's other situations, like for example, startups. At some point when startup scales, they acquire such a large amount of users and they don't know what to do with them. They don't know how to classify them. They don't know how to understand those users. What are their shopping behaviors? What are their interests? What are their backgrounds? They're not going to tell you their backgrounds. You know more or less some things based on their zip code, based on whatever you can think of. And with all this information, you're able to create groups. These groups you're going to use to later market them in a specific way or triggering a specific behavior on the website. And this is what clustering can actually help you do. It's basically segmentation applied to data science. Anomaly detection. This is one that I love. So one thing we said before actually is AI is all about data, about the data you train models with. The thing is, everyone thinks that AI is smart. AI is not smart. AI learns with data. If data are biased, so is the model. And the thing about this is that if there is very little representation of something, like of women in powerful positions, like a model is not going to predict a woman as the one that holds the power in a country, for example. If the most representative type of customers are the normal ones, how am I going to detect fraud? Actually, I think retailers have like a percentage of loss due to theft of 3%. So that is like a super narrow percentage of customers. So, well, no, they're not customers because they don't shop, they just steal. But imagine in a bank, like people who commit fraudulent types of activities. Those are not representative of the customer base that they have. So how do you recognize them? They are such a small segment. By default, an algorithm is not going to recognize it. It's going to ignore it because it's a small percentage of the data. This is a phenomenon that is called imbalanced data. When your target variable is affected by the representation of that data, you need to manipulate your data a little bit so that you can get your model to perform accurately. To commit fraud in my marketplace, this is an example I always give. Imagine a marketplace like Amazon. Considering the amount of vendors that I'm acquiring every single day or every single week, I don't know the numbers in this, but I don't know how to detect it. And even if I had a full-time person, what would they do? Call them and say, hey, what do you do? No, they would allow them to start selling, and then if a user complains, if someone complains, they will determine, suspicious activity. Customers complain about the product not looking like the pictures, then this could be a fraudulent vendor. There were behaviors before that vendor starts selling that are quite representative of what would identify a fraudulent vendor early on. Those are behaviors that you might not notice, but basically this is the way that also security people work in stores. And I don't know if you see security people who are watching, like they're like, got my eye on you. And basically they are following people through the aisles because they are like, okay, people with bulky coats might be prone to theft. People who are looking around the whole time are prone to theft. Those are basically patterns they've identified and that they are using to determine whether someone is a thief or not. And something similar happens with AI, but the thing is, that small amount of data, you need to increase that amount of data. You need to basically multiply the amount of data or reduce the rest of the data so that you have a model that is properly performing to the type of problem you want to solve. Recommendation system. So for example, have you ever thought, hey, I didn't tell Netflix anything from the stuff that I like. I didn't give them any feedback about whether the stuff they're recommending me is good or not. And they are giving me recommendations that I'm enjoying. How is this possible? Actually, they don't play so much with what it is that you say you like. It's more about what other people similar to you actually like. And those are recommendation systems that are also working with AI. Same thing happens with Spotify or, I know, recommendations of products like on Amazon. When you're looking at one product and you have a list of similar products based on the image of what that product is. NLP, natural language processing. This is like one that I was actually going quite deep in during my time. This applies to large language models. This applies to search engines, things. This applies to chatbots. I don't know, so many things. Basically, what you do is an interpretation of human language and trying to use computer science basically to give it a meaning, to understand, okay, what is this person trying to say? What does this mean? What could I interpret from this? Is this positive or negative? What is this user complaining about? You can use NLP to try to get the insights. Understanding what human language is trying to say in the context of search, Googling. Have you ever realized I Googled something that doesn't make a lot of sense, but then the result actually is good? It's not a coincidence. That is out of something called semantic search. When it comes to search, you have lexical search, which is an exact match to what you were looking for, and then there's semantic search, which is a match to the intention that you actually had. For example, if you were Googling Apple Granny Smith, most probably you're making a search for the Apple Granny Smith, like a green apple that is shiny. I really like them. I don't know if you like them, but that is not the same type of intention that you're gonna have when looking for apple than if you search for apple 14 inches. Most probably you're not searching for an Apple Granny Smith or any kind of fruit apple. You're most probably searching for a computer, right? That reflects an intention. So that is where semantic search comes in place. Another type of problem, computer vision. This is another one I find it super fascinating. So basically you recognize within images different items, like you identify objects, you extract information, you extract features from images, you analyze videos. Once when I was in Mexico, I met an exporter of fruits, and they were explaining how expensive it is to make a mistake when selecting the fruit to ship to Europe, because the logistical cost of shipping that fruit to Europe is much more expensive than the fruit itself. Shipping a bad fruit means someone might reject it because of the quality, and that's because you didn't choose the proper fruit. Things like computer vision, image recognition are super good to determine, much better than a human eye, whether a fruit is going to be good for the vendor. When it comes to size, determining what type of class of fruit it is. Another thing you can do with computer vision is kind of use supervised learning, unsupervised learning, and video analysis into something like self-driving cars, like determining where they need to turn, whether they should brake, whether they should keep driving. These problems are so fascinating. Like initially it's just learning without any kind of supervision. This is another problem that can be solved with AI. Optimization problems, like when Amazon decides to organize their warehouse, determining how to organize the products and the most optimized routes to actually collect those items based on statistics and different route planning options. Like you use AI to actually plan those things. Same thing as when Uber determines the right route for a driver to take towards picking up new passengers, or what are the suggested areas to go to. Those are optimization problems. Time series analysis, determining stock values, the possibility of a flight being cancelled based on previous data. Anything that could help you understand a little bit more of what can happen in the future based on data from the past. Revenue management most probably is also related to time series. My brain is so dense right now with so many topics. Then there's other topics like causal inference. It's not only about correlation between marketing campaigns and sales, but actually which ones are the ones that imply causation, like other problems, for example, like reward or punishment types of learnings. Like I met once a guy who was pretty cool. He was training a machine that would beat any computer playing Backgamon. And basically this is like a classic example of reinforcement learning. Like whenever you win a game, this is good. Whenever you lose a game, this is bad, right? And something similar happens. Like at the beginning, I don't know if you remember, with ChatGPT was sometimes asking you to evaluate the answers. Like, is this good or is this not? We thrive on reinforcement learning. This is how we teach our pets. This is how we teach our kids by telling them, oh, very good or oh, very bad. Like how to behave around the city. Like, well, it's mostly around punishment. Like if you're kind to people, people behave well. So this is a reward. Same thing happens with AI, like continuously learn based on additional input. The input can be as systematic as winning or losing a game, which happens when some criteria is met, or the input can be like when something else happens. For example, if I don't know if you heard of this news piece of drones and military systems that were being trained with AI, and apparently in this simulation, like they were aiming at the control tower. The way that AI works is basically optimizing towards target. It's data, target variable, and optimizing towards a target variable. And if in this case, like with this drones and military system, I don't know if this is a myth or not. I don't work in the military, so I have no clue. But if you have a system that is aiming at getting rid of the enemy, and the control tower is telling you, hey, like you cannot shoot now when you know you have a good shot, and basically you get rid of the control tower because you know you have a good shot, so you're gonna get the shot and you're then gonna get rid of something that is blocking you from reaching that target, from hitting that goal. It's not reasoning whether it should do that or not. It's just statistically understanding probabilities of winning if I listen to this control tower, and probabilities if I don't listen to this control tower. And if at some point, like, I know an operator tells me, oh, you cannot do that, I'm gonna get rid of the operator as well, because it's also going against. And you know, when it comes to the military, there's a long game, there's a strategy there. It's not about doing something for the sake of something. It's a little bit of Sun Tzu in there, right? It's not about only hitting a target, it's also about what it means to hit a target at the moment. So for example, I could maybe easily take down an opponent, but this means that the opponent is gonna discover me right now, so I don't want to do that. Or I could hit an opponent, but I could wait to see what the opponent is doing, and then I make a decision. If the model is optimized just to hit the target, you are going to be an obstacle to that target. So this is actually one of the kind of dangers that AI has. Like, I was seeing that people are saying, is AI good or bad? Well, depends. For what? Because AI is going to be logical. It's not going to be thinking about things the way that you think about them. Write a comment if you feel there's something worth mentioning, or just engage with any of the options in YouTube. Thanks a lot and have a nice day.